Swayam Prabha. Digital India. Educated India.
As I mentioned in the previous class, when you have a circuit with a single pair of terminals, that is a linear circuit with a single pair of terminals, it looks like a resistor. Okay, I am considering circuits without any independent sources inside. Now, when you have a circuit with two pairs of terminals, we have to find the right representation for it. We know that in a linear circuit, every quantity will be a linear combination of the sources that are applied to the circuit. When I say every quantity, I mean every branch voltage and every branch current. Okay. So this linear combination can be represented in different ways, and they give rise to different sets of two-port parameters. Okay. Let's say this is a single terminal pair, 1 prime. And when we have two terminal pairs, we have to relate V1 I1 to V2 I2. Okay. So that relationship, let's say you relate I1 and I2 to V1 and V2, it gives you a set of two-port parameters. Okay. As I had mentioned in the previous classes, unfortunately the setup here is such that I cannot take questions by audio. So please ask your questions on the chat window. Now, this also can be further generalized to many ports. We will not consider that, but I'll just show you here. If you have, let's say, n terminal pairs, you can relate voltages and currents at these terminals. Okay. Now, a particular reason for considering two ports is that many systems we know have one input and one output, and they correspond to this two ports. That is, they are well described by this two-port representation. For instance, amplifiers. If you have an amplifier, there is an input and an output, and it's described by this representation. Okay. So that's why they are represented by two ports. Okay, so that's why we'll study the two-port parameters in some detail. I think participants are raising hands to ask questions. As I mentioned, I will not be able to take questions by audio. So please use the chat window to ask any questions you have. Now, I also took an example of a simple circuit and showed that the quantities will be linear combinations. So let me take this example where I have two terminal pairs. Okay, and each terminal pair is called a port. This is port number 1, this is port number 2, and each port has a voltage and a current, and these voltages or currents voltages and currents are defined in direction consistent with the passive sign convention. That is, V1 is with plus on top, then I1 goes into the upper terminal. Similarly for V2, sorry, this is V2. Okay. Now, we can apply either voltage sources or current sources to either side and measure the remaining two quantities. Okay. So, for instance, we can apply V1 and V2 and measure I1 and I2. When I say measure, what I mean is I write I1 and I2 in terms of V1 and V2. Okay. Alternatively, I could apply I1 and I2 and measure V1 and V2. Okay. And I could also apply V1 and I2 and measure I1 and V2, or I apply I1 and V2 and measure V1 and I2. Okay. So all these are possible. So for each of these, there is a set of two-port parameters that will describe the relationship. Okay. So what do I mean by when I say I apply V1 and V2 and measure I1 and I2? It means that I have voltage sources connected to the two ports, and then I will write I1 and I2 in terms of V1 and V2. Okay. Now clearly I1 can be written as some number y11 times V1 plus some other number y12 times V2, and similarly I2 can be written as some third number y21 times V1 plus a fourth number y22 times V2. Okay. So we discussed this in the previous lecture. Now these numbers y11, y12, y21 and y22, these are numbers with dimensions of conductance. Okay. Now the numbers that appear here will depend on the parameter set we choose. In this case, we are writing currents as something proportional to voltages. So these will have dimensions of conductances. Okay. Now we also said that this kind of relationship comes about because this whole thing is a linear circuit. Okay, that denotes the effect. Okay, and the second one, the cause. What I mean is this y11 relates I1 to V1. Okay, so this I1 means the first subscript is 1 and it is due to V1 means the second subscript is also 1. Whereas in this case y21 relates I2 to V1. Okay, so in general YKL will relate IK to VL. Okay. So this is the convention that is used. So again, let me, if you want to, if you didn't understand how these relationships come about, first of all, it is a linear circuit, right? So linear circuit means superposition will apply. Okay. So you can think of this as superposition of two cases where one where V1 is 0 and the other one where V2 is 0. If V2 is 0, both these currents will be proportional to V1. Okay, so we will get this part. And if V1 is 0, both of these currents will be proportional to V2. We will get that part. And if you have both of them non-zero, then you get the sum of the two. Okay, so this part comes about when V2 equals 0, and this part comes about when V1 equals 0. Okay. So now let's say you are given a circuit with two ports and you are asked to determine the values of these parameters. What will you do? How will you measure it? Please give me some ideas. Let's say how will I measure the value of Y12? Okay, you can relate this to earlier examples we did many times. That is, if you have a one port, okay, then you want to find out what it looks like looking into this terminal pair. What we did was to apply some test voltage and measure the current. Okay, so taking the ratio of voltage to current, we get the resistance looking into this one. Okay. Similarly, now in this case, I want to measure Y12. What should I do? What is it that I can do to measure the value of Y12? So in general, to measure any of these things, you have to set some voltages to 0 and apply only one voltage. Okay, so instead of applying both voltages simultaneously, you have to apply just one of them. Okay, so let's see. Now, first of all, let's say I set V2 to 0. Okay, so if I set V2 to 0, it's the same as saying that port 2 is short circuited. Okay, so if I substitute that with V2 equal to 0, what I'll get is I1 is Y11 V1. Okay, so Y11 is nothing but I1 by V1 with V2 set to 0. Okay, similarly I2 would be Y21 V1 and Y21 is I2 by V1 with V2 set to 0. Okay, so to measure Y11 and Y21, you have to apply V1, short circuit port 2 and measure the currents in port 1 and port 2. Okay, so I think this is pretty obvious from the equations. If I set V2 equal to 0, the second part of these things go away, and you will be left with only this, and then you can find each parameter individually. By measuring I1, you can measure Y11. By measuring I2, you will measure Y21. Okay. Similarly, it's also very clear that Y12 can be measured by setting V1 to 0 and measuring I1. Okay, you measure I1 by V2 with V1 equal to 0. When V1 equals 0, this part goes away and Y12 will be I1 divided by V2. Okay, and similarly Y22 will be I2 divided by V2 with V1 set to 0. Okay, so I hope this is clear. So Y11 and Y21, these are measured with port 2 short circuited, and Y12 and Y22, these are measured with port 1 short circuited. Okay. So that's why these Y parameters are also called short circuit parameters. Okay. So Y11, which is I1 by V1 with V2 set to 0. And what is I1 by V1? It is current going into port 1 divided by the voltage applied at a port at the same port. Okay. So if you apply a voltage between some pair of terminals and measure a current through the same pair of terminals, it is like measuring the resistance or conductance across that pair of terminals. Okay. So this is nothing but conductance at port 1 with port 2 short circuited. Okay. So if you imagine the picture, we will have it like this. Okay, so this is how we are measuring Y11. Okay, so it's pretty clear that once you short circuit this, you can think of this as a single port network when you are measuring I1. Okay, so you are applying V1, measuring I1, taking the ratio of the two, I1 by V1. So it is like measuring the conductance between this terminal and that terminal. Is this clear? Now, if you look at Y21, it is I2 by V1 with V2 equal to 0. The picture is the same except that you are not measuring I1, okay, but you are measuring I2. Okay. Now you are applying a voltage to port 1 and measuring the current in port 2. Okay. So this one is not a conductance. Conductance is when you apply a voltage to some pair of terminals and measure a current going into the same pair of terminals. Here you are applying a voltage here but measuring the current on the other side. So this kind of a thing, it has dimensions of conductance. It's I2 by V1 but it's at different ports, and this is known as transconductance. Port 1 to port 2 with port 2 short circuit. Okay. So Y11 is like a conductance and Y21 is like a transconductance from port 1 to port 2. Transconductance means that something that you apply here has an effect on that port. Okay. So now please give me the interpretation of Y22. Okay. What is Y22? We know that it is I2 by V2 with V1 equal to 0. So please give me sort of the verbal interpretation of what this parameter is, Y22. Yeah, so that is exactly right. This is conductance at port 2 with port 1 short circuited, and similarly Y12, which is I1 by V2 with V1 being 0, is transconductance from port 2 to port 1 with port 1 short circuited. Okay. So now when I say measure, it also applies to calculations. So when you are given a circuit and you are asked to calculate the Y parameters, this is how you have to do it. Okay, to calculate Y11, you short circuit port 2, measure I1 and divide it by I1 to get Y11. Okay, and so on. So we will take an example of this later. Okay. Now another thing is the equivalent circuit. Equivalent circuit representation. What do I mean by this? Again, let's go back to one port. So if I have a single pair of terminals, okay, then we know that this I1 will be linearly related to V1, and at these two terminals we can always represent any linear one port with an equivalent resistance. Okay, this Req will be nothing but V1 by I1, and we can also find the conductance if we want. So my question is now we have to do a similar thing for two port. That is, this circuit, this very simple circuit, is the equivalent of this whole box, whatever complicated circuit be inside. As far as these two terminals are concerned, that is very important. When we say it is equivalent, we should find out where is the equivalence. These two terminals, the voltage current behavior will be the same as in this complicated circuit. Inside this, you could have hundreds of resistors and linear control sources and so on. So all of them will finally reduce to this linear relationship between V1 and I1. So similarly, for a two port, we have to come up with a relationship. Okay. That is, we now have equations which describe the behavior. Okay. Now I would like to have a circuit representation of this sort. Okay. So what is that going to be? So let me copy over this part of it. So let me take each term one by one and then try to make a representation. So first of all, I'll take this part I1 and I'll take the first term of that Y11 times V1. Okay. So if I have I1 equals Y11 times V1, and let me draw the two port here. So I should have some circuit element which will realize this relationship. I want I1 to be proportional to V1 with this constant Y11. Okay. So what is the circuit element that will realize this relationship? And where should I connect it in the circuit? That is, I have four terminals here, 1, 1 prime, 2, 2 prime. So what is the circuit element that will realize just this relationship, where I have taken only the first term in I1, and how do I connect it so that I get just this relationship? This should be pretty simple. In fact, you can very easily see that it is more or less equivalent to a one port network. So again, I think you are able to get the answer quite quickly. So this, you see, is just a conductance Y11 connected between I1 and V1. Okay. So when I write Y11, Y11 has dimensions of conductance. So when I write a resistor and write Y11 next to it, so that means that the conductance of this resistor is Y11. Okay. So this will clearly realize if I apply V1 here, a current will flow which is equal to Y11 times V1. Okay. So now let me take the first term of the second equation, the equation for I2. Now what is an element that will realize this? That is, I want to now realize I2 equals Y21 V1. Okay. So what is the element that is going to realize this, and how do I connect it to this circuit? Here it says that the current in 2 prime is proportional to the voltage across 1 prime. So what is an element that is going to realize this relationship?